All right, guys, in this video, we're going to work on triangle inequalities in just one triangle. Okay, so the first thing here, it just says that the largest side is across from the largest angle. The smallest side is across from the smallest angle. As you see here, there's 6, 9, and 12. 12 is the longest side, so it's across from the longer angle, the biggest angle. 6 is the shortest side, so it's across from the smallest angle. Okay, so since 12 is bigger than 6, y is bigger than z. All right? And then x would also be bigger than z because 9 is bigger than 6. So here it says to list all the angles from smallest to largest. You would think, well, that's pretty easy. All I have to do is look at the side lengths. Well, in this case, I do not have the side lengths. How can I solve for x here? Let's think back to what we know. Yep, Pythagorean theorem. Because we have this right triangle here, we can do Pythagorean theorem. So that gives me 12 squared plus x plus 1 squared is x plus 9 squared. 144 plus, remember, this is x plus 1 times x plus 1, x plus 9 times x plus 9. So I get 144 plus x squared plus 2x plus 1 is x squared plus 18x plus 81. I'm going to bring everything to the same side. When I subtract the x squareds, they will actually cancel each other out. So then I'm just looking forward. Excellent. You are excellent at algebra. I'm going to bring this 2x over here and get a 16x. And I'm going to bring this 81 over here. Excuse me. Yep. And then let's do this 145 plus 81. So you have to combine those like terms. I'm going to subtract the 81, get 16x. 64. X is 4. And don't forget to combine those two right there. So x equals 4. So if x is 4, that gives me 13 and 5. And if remember, that's a perfect triple, 5, 12, 13. So it's asking for the angles from smallest to largest. So the smallest angle must be across from 5. Angle C, angle B, angle A. Don't go by what it looks like, go by what the algebra gives you. Doesn't matter that this looks bigger than that. Go by what the algebra tells you. All right. So if we know the bigger angles across from the bigger side, the converse of that is the bigger side is across from the bigger angle. Okay. So here, we're going to list angles, or sides, longest to shortest. So if I'm going to do that, I'm going to have to do my triangle angle sum theorem. So I'm going to have to do 180 minus 148 gives me 32. So my longest side is QS. It's across from R. Then my next longest is RS. And then QR. Because QR is across from the shortest side. All right. Last, the triangle inequality theorem. What that states is that any two sides, the sum of any two sides has to be greater than the largest side. So red and blue must be bigger than purple. Purple and blue must be bigger than red. Okay? Red and purple must be bigger than blue. So it's pretty simple to see if this works. Take the two small sides, 3 plus 7, is it greater than 8? 10 is greater than 8. So yes, a triangle can have those sides. 5 plus 10, 15. Is it greater than 15? 15 equals 15. No, it can't be equal. It has to be greater than. It's not greater than or equal to. It has to be greater than. All right? So any two sides have to be greater than the third side. To make it a little more complicated, it might give you two sides. So we have 5, 8, and we don't know the third side. What is the possible value for that third side? It's a range. We're going to find a range of values. So, well, the first thing is 5 plus 8 must be greater than what? X. Okay, another combination. 5 plus X must be greater than 8. And 8 plus X must be greater than 5. So we have three possibilities. You set up all three. One's greater than X, one's greater than 8, one's greater than 5. That's how you do this. When it's looking for the range, add 2 greater than the third and do all three combinations. So I have X is less than 13, X is greater than 3, X is greater than negative 3. First thing you do, find the one that's by itself. That's at X is less than, because we read the variable first. X is less than, X is greater, X is greater. Well, that has to work. It has to work. X has to be less than 13, because there's no other choice. Now it has to work for both of them. So we think this out. If I'm looking, let's do a quick, I got 0, 3, negative 3. I got X is greater than 3. I got greater than negative 3. It has to work for both of them. So to work for both of them, it has to be greater than 3. Greater than the greatest, less than the least. Greater than the greatest, less than the least. Okay. We have a couple students complete for you to work on your own. Okay, this is a nice problem. I really like this. Take your time doing this, all right? I'm not expecting everybody to get it right, but I really want you to take your time doing this. We're going to spend some time on this in class. Okay, we have another range problem. All right, guys, work on those, turn them in, and I'll see you next video.